we're going to do some example problems of how to find the area of a rectangle given two polynomials or potentially more. So our example problems are going to be from our note sheet, and we have two different scenarios here where we're trying to find the area of the shaded region. In the first one on the left hand side, our shaded region is that green area around that white spot. So what we're going to have to do eventually is we're going to have to find the area of the whole rectangle, and then we're going to have to subtract out the area of the little rectangle, so we're left with just the shaded area. So our formula is going to look or our process is going to look something like this. Area of the big rectangle, I'm just going to say area of the big, minus or taking away the area of the small rectangle. All right, so we can break this down into kind of two little mini problems. So let's start by thinking about the area of the big rectangle. In order to know the area of the big rectangle, I need to know the base and the height. Area equals base times height. Well, unfortunately, they do not tell us the length of this long side, so I'm going to have to figure that out. What I know from the information that they gave me is that that piece from the inside is 9x, and then I know these little bits on the side are 3. So when I combine all of that together, the length of that long side would be 9x plus 6, because I have 9x plus 3 plus 3. Then when we look at the sides, it's very similar. We know from here to here, based on our inside rectangle, that is a length of x. And then those little bits on the end are also 3. So the length of my side would be x plus 6. So to find the area of the big rectangle, I need to multiply 9x plus 6 with x plus 6. I'm going to multiply using the box method. I'm going to set up a 2 by 2 box. I'm going to put 9x plus 6 on one side and x plus 6 on the other side, and I'm going to multiply the terms that meet in that box. So in this first box, it would be 9x times x, or 9x squared. 6 times x would give me 6x. 9x times 6 is 54x, and 6 times 6 is 36. So the area altogether of that would be 9x squared plus 6x plus 54x plus 36. Well, we can combine like terms here. We have 6x and 54x. So in total, I have 9x squared plus 60x plus 36. That is an expression that represents the area of the big rectangle. Now let's look at the area of the small rectangle. I need my base and my height of my small rectangle, which was given to us. So 9x times x. Well, this one I don't have to do a box method for because I'm just going to add those exponents together to get 9x squared. So now to find the area of the shaded region only, I'm going to take my big rectangle area, 9x squared plus 60x plus 36, and I am going to subtract my small rectangle. I'm going to subtract going vertically. It does not matter how you subtract vertical or horizontal, but what I'll notice is that those 9x squareds are going to add to 1 or subtract to 1. So I'm left with 60x plus 36. This is an expression that represents the area of that shaded region. So just the green part around the outside. Okay, let's look at the second one, which is slightly different. Here we don't have any sections that we're taking away necessarily, but we have a bunch of sections that we're going to be adding together. So I'm going to have to find the area of each individual rectangle. At least that's the method I'm going to use in this case. There are other methods here that you could use, but let's start with that black arrow that I have there. I'm going to take my base times my height, so x times x plus 1. And in this case, I could use a box method, but I'm going to distribute instead to give us x squared plus x. So that's my first little rectangle. Now let's look at the big one. we have x plus 5 times 2x as my dimensions. So 2x times x plus 5, I'm going to distribute to get 2x squared plus 10x. And then my last one, I have x times x. Don't really need a box for that at all. And so now I want all of those areas together. So I'm going to add all of those little pieces up. To add, I'm going to look for like terms. So I have an x squared, a 2x squared, and an x squared. Those x squareds just have ones in front of them. Oops, wrong pen. So in reality, I have 1 plus 2 plus 1x squared, or 4x squareds. Then I'm going to look at my next like terms, which are 1x and 10x. If I add the 1x and the 10x together, I get 11x. This is an expression that represents the area of that entire shaded region. So sometimes you'll be adding areas together and sometimes you will be just subtracting. I hope this helps. Have a great day.